Hello and thanks for joining me today. We are talking stoichiometry. We are doing mass to mass conversions. So it's just a bit of an extension from going moles to mass. So let's get started. So goals for you today. You're going to be able to use your knowledge of stoichiometry to convert between grams of substance A to grams of substance B. So we're going from one substance here to grams of substance B, or the other way around, whatever you want to call B and A. It's kind of arbitrary. So here's the deal. We can have balances in that they don't measure directly in moles. We don't have something to measure in moles because it's different for each substance. Instead, we usually get our amount of substance by measuring mass in grams. And so with this, we can take the mass of a reactant or product and we can go to the mass of any other reactant or product. So anything in that specific equation or reaction can be calculated. We have to use mole interpretation, I should say, of a balanced equation, is the basis for this conversion. We're going to talk about this and what this means right now. So this is how it works. If the sample is measured in grams, we know the mass in grams. We can convert from grams to moles using the molar mass. So step one is grams to moles. And I'm going to write this again. You're going to get this a lot of times. Don't worry about writing it now if you don't want to. Grams to moles is step one. Grams of, I'm going to put A here. Grams of A to moles of A. Then we have to use our mole ratio. So we can go to a different substance. So we go grams to moles of A, and we go moles A to moles B. And then last but not least, it's the mass that needs to be determined. We can go from moles to grams by using the molar mass. And so we go moles B, that's an E, to grams of B. So this should be a 2 instead of an arrow. Moles, grams of A to moles of A, moles of A to moles of B, and moles of B to grams of B. Okay, so this is what we're going to do. So here it is again. So we can go mass to moles. So this G means given. So you can go mass to the given, so moles of your given. Go mass to moles by using your molar mass of G. So mass of G times your grams per mole is molar mass. I don't like that at all. That's kind of not in there correctly. You should take mass divided by molar mass. Mass divided by molar mass will convert to moles. Okay, and then you're going to take your moles of your given, which you just calculated, to change the moles of the things you want, which is the W, by using your mole ratio. So moles of G to moles of W using your mole ratio, and then moles of W to grams using your molar mass again. So let's see this in action, shall we? So we go from the mass of A to moles of A using your molar mass. We go from moles of A to moles of B using your mole ratio. We go from moles of B to grams of B using your molar mass of B. And then I'm actually going to, so I'm really big on mole mountain. So if we have moles of A, we can go from mass or particles, both of A, over to moles of B. And again, we have mass of B and particles of B. Okay, and if you follow the train tracks up and down, you can really walk yourself to the answer. And that's what I love about Mole Mountain, is you can walk yourself. So if you're in grams of A, you can say, okay, to get from grams of A to grams of B, I have to first go to moles of A. I'm going to follow the arrow, follow this up arrow, and molar mass is in the middle. Just put double M for molar mass to go from moles to moles of A. And because this up arrow has molar mass on the bottom, you're going to divide by the molar mass. Now I'm in moles of A. I have to use my mole ratio to go from moles of A to moles of B. And I'm going to put words on top and bottom because you can multiply and divide depending on how we're going here. Once I'm in moles of B, so that's step one. Step two is to go to here. Sorry, that's a really bad line. That's step two. This was step one. Once we're in moles of B, we're going down to grams of B. And again, this molar mass is in the middle. And it's above this down arrow. And so I'm going to multiply by the molar mass to get to grams of B. Okay, so let's put this into practice. Let's see how this looks. And we'll go from there. So calculate the number of grams of NH3, which is ammonia, produced by the reaction of 5.40 grams of hydrogen with an excess of nitrogen. Okay, so step one, you gotta write your balanced reaction. We know that hydrogen is diatomic, reacts with nitrogen, also diatomic, to produce NH3, which is ammonia. Okay, step one, write it correctly. Step two, is going to be to balance this thing. Okay, so I know that I have 3 hydrogens here and I have 2 on this side. 3 and 2 both go into 6. So I put a 3 here, I put a 2 here. Those are balanced. I have 2 nitrogens and I have 2 nitrogens were balanced. Everything's done. Perfect. Okay, now, things that I know. I know that I have 5.40 grams of hydrogen and I am trying to find my ammonia. Okay, so let's see this in action. So I have 5.40 grams of, grams of H2, maybe. Okay, so step one in our list of things to do, we have to go from, remember mole mountain, we have to go from grams of, let's backtrack quick. So mole mountain, I'm at grams of A. I have to go from grams to moles. So we have to use the molar mass and we're going to divide, it's on bottom. So if I'm going here, I'm dividing by the molar mass of hydrogen, which is 2.02 if we round, grams of H2. And that's for 1 mole of H2. Okay, that's step one. Step two, now I'm at the top. I'm at moles of A. I got to get to moles of B. So to do that, I have to use this mole ratio in the middle. Alright, so my ratio of hydrogen to ammonia. I have 3 moles of hydrogen, this 3 here. For every 2 moles of ammonia, the 2 there. So because hydrogen's on top, I need 3 moles of H2 on bottom. And I need 2 moles of NH3, that's what I'm going to, on top. That's step 2. That's step 2. Okay, so now I'm at moles of B. To get from moles to grams, we have to use step 3, which is going to be this way. So we're using this arrow. Molar mass is on top, so we're going to multiply by the molar mass in step 3. So I know that 1 mole of NH3 is equal to 1 nitrogen and 3 hydrogen, so 3.03 plus 14.01 should be 17.04 grams of NH3. Okay, and that's what I wanted to end up with, so we should be good to go. If I check my units, I have grams of hydrogen and I have grams of hydrogen. Those are going to simplify down to 1. Moles of hydrogen, simplify down to 1. Moles of ammonia, simplify down to 1. I'm left with just grams of ammonia left, which is perfect. If I multiply all of this out, I take 5.40 divided by 2.02 times 2 divided by 3 times 17.04, and I get 30.368, which is going to round sig fig wise. I started with 3 here, so I need 3 in my answers. So 30.368 rounds to 30.4 grams of NH3. Okay, so that's how you do mass to mass. And we could solve for nitrogen as well if we wanted to. If you want to do that on your own, that would be great. But I'm not going to ask you to do that here. I'm going to give you a different question. Okay, so here, this is your question. If 5.00 grams of oxygen gas are reacted with the nitrogen gas to produce water, how much water will be produced? If you work this through, you should get an answer of 5.63 grams of water. If you get something different, double check your work, double check your steps, but we missed something along the way. So that's your practice to do. There's your answer, so you know what you should get when all is said and done. Here are some closure questions I'd like you to be able to answer. So you need to be able to tell me and kind of walk me through the steps to convert from grams of one substance to grams of another substance. It's the essence of this lesson. Last one. How much carbon dioxide is produced by 10.0 grams of propane, C3H8, burning in the presence of oxygen gas? If you can solve that one, that would be fantastic. Next time you get to talk to me, next time you talk to me, we'll talk about limiting reactants. And we have multiple things. So if you know how much propane and oxygen are both present, how much CO2 should I get there. So thank you guys very much for joining me today. I will see you again next time, and take care until then. Bye.